Hey there, YouTube. This is Ash. I'm here to help you crush your coding interview. I've spent 16 years as a professional software engineer, and I've interviewed with most of the big tech companies, and I worked at Amazon for a little while and conducted coding interviews on behalf of Amazon, so I've learned a lot about what it takes to succeed in a coding interview, and unfortunately, I learned a lot of it through pure trial and error. So I'd like to save you some of that headache, and I'd like to help you land your next job as a software engineer. All right, so today I'm going to be taking you through the unique sum problem, also sometimes called the two-sum problem, on this whiteboard using JavaScript as if I were in a real job interview. So let's dive into it. The two-sum problem, or unique sum problem, says given an array of integers and a target value, in this case target value of 5, and this array of numbers, find the indices of the two numbers that can be summed together uniquely to form the target value. Now, one of the first things you got to make sure you do is you understand any assumptions and limitations that the problem has. So my first question here to the interviewer would be to understand what this unique word means. In this case, it means we won't ever have a target value of 10 in this case, because 6 plus 4 could be 10 and 8 plus 2 could be 10. So there's no unique sum there, so that would not be a valid target value. Also, while it's implied, I would also double check that we are guaranteed to find the answer within here, right? Like for instance, if somebody were to give you a target value of 15, there's no way you could get to 15 using the numbers inside this array. So double check those assumptions and make sure that you and the interviewer are on the same page. All right, so without further ado, let's dive into the coding. So one of the first things I always like to do before I start writing any code is I like to jot down any thoughts and ideas I had when I was reading over the problem to make sure that I keep those tidbits of information close at hand in case I need to refer back to them. In this case, I would just kind of come up with a little mathematical model of how I see this problem. So I've got a target, which is the sum of two values, x plus y. So when we look at this, we know that we have a target and we happen to have two values that will sum to that target. We're guaranteed of that. So now we just need to write an algorithm that'll help us get there. So, all right, we've got that. And then sometimes I like to just kind of draw some sample data on here too. So here's my numbers array from earlier, 6, 8, 4, 2, -3. And what I can say is, all right, how would I solve this in the simplest, most brute force way possible? I always like to start with the brute force approach because it allows the interviewer to see my entire thought process from the simple approach to the more complex approach. And it also alleviates some of the pressure in case I can't come up with that optimal solution later. At least if I've described a brute force solution, I could implement that worst case scenario and the interview wouldn't end too badly. It wouldn't be as good as an optimal solution, but it's better than completely failing to give a solution. So one of the reasons I like to draw what the data looks like on here is because then I can kind of say, okay, well, what would the brute force solution look like? So as I'm thinking through this, the way that we would just solve this by looking at it is kind of, a polynomial solution, right? We're going to traverse the array multiple times and we're going to compare every single element against every other element, and that's going to end up being an n-squared suboptimal sort of solution for this problem. A lot of times n-squared solutions are very optimal, but for something this simple, we should be able to come up with something in linear time. And so then you start thinking about it and you say, okay, well, if I need to come up with this in linear time, then that means I'm only going to see every one of these elements once. I need to be able to iterate through this entire array once, and by the end of that iteration, I know what my answer is. So a little trick that you can do is that every single time you stop and you examine a single element in the array through your iteration, you can go ahead and jot down some notes in a data structure somewhere so that if you come across its counterpart element later on, hey, you know where the first element was, and now you found the second, and you can take those two indices and you have your answer. Now, the way that we can do this the most easily is, I think, by rewriting this equation to say y equals target minus x. That's going to prove to be very powerful here in just a moment. And as soon as I dive into the code, you'll see why. So now as we're diving into the code, one thing to keep in mind is that as a software engineer, your job is to make sure that you write code that's going to be resilient. So that means you have to address any edge cases, and edge cases are something you should absolutely address during a coding interview as well. So let's dive into this and write this code just like we would if we were on the job, not pseudocode, but actual code. All right, so let's go ahead and say const sum, and we can say this equals a function that takes in an array called nums and a target value which will be an integer. Okay, so the first thing that I would do right away is I would address the edge cases involving the arguments, right? So in this case, I would go ahead and tell the interviewer, hey, look, I'm going to go ahead and assume target is always going to be a valid integer, but I am going to check the edge cases on nums. Now, they may say, well, could you also check on target? I'm just going to say they'll probably let it go. So I'll go ahead and say if not nums, so this is when the nums array is null or undefined, or nums dot length equals 0. And you could have just done not nums dot length, and if it's a JavaScript shop, they may actually say, oh, cool, yeah, that's a little bit more JavaScript-y syntax. So in this case, where we have an undefined or a zero-length nums array, I would just tell the interviewer, hey, look, in the case of invalid inputs, I'm just going to go ahead and return undefined. Is that cool? And usually they'll say, yeah. So we'll just go ahead and return. All right. Okay, so now after we've addressed our edge cases, let's get into coding our actual solution. So let's go ahead and create a variable to hold our result that we will return. We'll just call it result, and we'll initialize it to an empty array. We're going to make this a variable, not a constant, because we are going to update it later. Next, let's go ahead and create a map. So we'll say const m equals new map. This is going to be a hash map that we can use to go ahead and store those notes I was telling you about as we iterate through every single element of the array, so that we know where to come back if we find the counterpart of an element we previously encountered. So let's go ahead and code up that for loop where we're going to iterate through that array. Now, rather than using a for each, I'm actually going to use a traditional for loop here simply because I need to break in the middle. And that's something you can't do in a JavaScript for each. Adding in little tidbits like that to the interviewer to let them know you understand the underlying behavior of the language is going to be a super great way to earn bonus points and to let them know you really, really understand how this language works and you understand software engineering. Okay, so let's go ahead, say for let I equals 0. I is less than nums dot length and I plus plus. And so within this loop, first we'll go ahead and handle the case where we check the map to see if we've already seen the counterpart of the current element. Now, for simplicity, I'll go ahead and say const x equals nums of I, which kind of refers back to this target equals x plus y formulation I had earlier. And then I'll go ahead and say if m.has a key that corresponds to this x value, then that means that we have already found the counterpart for this current element. Let's go ahead and grab it. So we'll just go ahead and say result equals the current index plus m.get x, which would be the index of the counterpart of x. And then we'll go ahead and just, whoops, not break. Let me say not return. We want to break. Now, I've put this all on one line here just because I have limited space on this whiteboard, but please don't feel like you have to do anything like that during an interview. Anyway, then we're going to handle the other case, which is, all right, well, the map doesn't happen to have it, but because we're going to break in there, we actually don't need an else. We can just go ahead and say, well, okay, so if we didn't find the counterpart would be target minus x. And let's go ahead and save that in our map and say the key is going to be that counterpart value and the index is going to be the current value. So basically what we're saying here, that's not x.I, that's supposed to be a semicolon, sorry. Basically what we're saying here is if we ever come across this counterpart value later on, then we know that the index of the current value will be its counterpart. It'll make a little bit more sense in just a second once I finish the code. So once we've done that, now we've done everything we need to do within this for loop. And we can just go ahead and return our result. Actually, and that's it. Done. Okay, I'm about to jump into analyzing the runtime complexity and giving you details about where you can find the code and the unit test for all of this on GitHub. But before I do that, if you're getting value out of this video, could you go ahead and please hit that like button? I really appreciate it. Thanks. All right. Okay, so now that we're done with the code, the next step is going to be analyzing this code for its runtime complexity. Typically, an interviewer is going to say, great, you've put together this code, now tell me what the runtime of this code is. They're going to be looking for a big O notation answer. So as we look at this, we say, all right, well, this is constant time, this is constant time, this is constant time. Oh, look, we have a for loop here. And this for loop, well, let's see, it's going through the entire array once. It may or may not break before the last element. So, hey, that's going to be big O of n. This is constant time, so it's big O of n plus constants. We drop all the constants. This is a big O n solution. Okay, so now we've written our code. We have analyzed its runtime. The very last step, or sometimes even before you get to the runtime step, that I always like to do is I always like to convince both myself and the interviewer that this works, right? I would not count on the interviewer having been able to follow along with all the logic and to know that your code works. And so I would just kind of step through it using some of this sample data, right? So I would say, okay, so if my target value was 5, then I know that my array should return 1 and 4. Does it do that, right? So we say if that's the nums array and the target value is 5, well, this is going to evaluate to false. Our result will be empty. We'll create a new map. And as we iterate through this, first x will be 6, and then the map will not have 6, and so then y will be 5 minus 6, which will be -1, and we'll say m.set -1 and the current index, which is 0. And so if we had this map somewhere over here, right, let's just pretend we have this little map, and so over here we've got the key, and over here we've got the value, right? Like you can even go ahead and draw this on here as you're working through the code. And I mean, once you've got your code written here, it's fine to mess around on the whiteboard as long as you're not messing anything up. So we'll go ahead and say, oh, okay, well that y value would have been -1 and the index value would have been 0. All right, so my next time through this loop, let's see, I'm gonna go through with 8. All right, so x equals 8. M does not have a key value of 8. So then y equals 5 minus 8, which ends up being m.set -3 and the current index, I, which is 1. And so if we go through this with the next value, so we get to x equals 4, there's no 4 in our map, target -4 equals 1, so we'll say 1, and this is going to be at index 2. And then finally, we get to our 2, and we say x equals 2. Does the map have a key of 2? No, it doesn't. So y equals 5 minus 2, which is going to be 3, and an index value, not 4. An index value of 3. Okay, so then finally we get to our -3. We say x equals -3. Does m have a key value of -3? Oh, look, it does. All right, so then result equals I, which is the current index, which is going to be 4. And then m.getX, that's going to return this 1. So this is going to end up returning 4, 1. Now, whether it's 4, 1, 1, 4, the order probably doesn't matter. In this problem, they specifically just asked for the indices, so there is no ordering matter. But please go ahead and double check that with your interviewer and say, hey, is it cool? Does the order matter? Chances are, with a problem like this, it doesn't. So we've worked through the problem, and typically I would usually work through maybe 2 or 3 cases. Try to spot an edge case, right? Like maybe add a 0 to your array, or if you didn't already have a negative, add a negative number. So just kind of try to work through some of those cases, and if you run into something that doesn't work, that's okay. Come in here and start modifying your code just a little bit. It's very, very common. It's happened to me in plenty of interviews where I've forgotten one little thing, and then I've had to come back about halfway through and modify some of my code, and usually it works out. Okay, so hopefully you all found that very helpful or informative or at least understandable. My goal is simply to help as many people as I can with their coding interviews, so please go ahead and leave a comment below if there's anything that I could have done to explain this a little bit better, if you have any questions, or if there are other coding problems you'd like me to cover. I'd like to post at least one of these videos per week, and I'm going to be looking for additional problems to solve on this whiteboard and post up. And I can also use other languages. If there's a lot of demand for Python or something like that, then I'm happy to try to accommodate that. Below, I have a link to GitHub, as promised, with the solutions, as well as some unit tests, so you can go grab that code. You don't have to worry about trying to copy down the scribble that I wrote up here. Please go grab that code, run it. If you find any issues or have any enhancements or ideas for it, please feel free to submit a pull request. All right. Thank you all very much. Wow, it's a sunny day in Seattle. It's kind of strange. I mean, usually this only happens like 6 days a year or something like that.